Hey everyone. More than one of you, I think, is a little frustrated with the current section that we're dealing with, 1.7, with the non-linear inequalities that are involving the rational functions. And I do understand the frustration because up until this point, you've been able to relate the skills that you're working to something that you know and you understand. So like if you're talking about a parabola or even a polynomial, you haven't been graphing higher level polynomials, but you're getting a sense for, okay, they're going to have more bumps and curves, right? So you're understanding the idea of zeros and factors and all that, and then you run across these rationals and things are not making sense. So rational functions are coming up in about two chapters from now. So if you would like to take a little bit of time to understand why these sign charts work the way they do, that usually also helps you with your accuracy because you kind of have a backdoor check for what you're doing. So I'm going to start with just kind of giving you a little bit of familiarity of what a rational function is and why we test them the way we do, okay? So I'm going to share over my screen to Desmos, where we're going to start with the parent form of a rational function, and that is this 1 over x, okay? Of course, every function kind of has its most basic form. And if you notice that 1 over x, if you think about this, if I plug in some values here, okay? Just think about what happens with this function. Well, 1 over, if my function of x is equal to 1 over x, okay? I'm going to first start with 0, okay? I'm going to do some negatives here and do some positives here. Well, notice if I try to plug in a 0 for x, I get division by 0, right? The function is undefined here. And if you notice, look at the graph, okay? The graph clearly shows you that at no point in time will it ever cross over this red line, okay? On the left side, it races to infinity along both axes here, and it's in the negative directions, right? Races to negative infinity here, and races to negative infinity on the y-axis. So this is my negative territory, and then this is my positive territory, okay? Here it's going to race towards positive infinity on the x-axis and race towards positive infinity on the y-axis. There's a good reason for this. This turns out to be very important in calculus, okay? So let's go back, all right? I'm going to do -1. If I plug in a -1, well, I get 1 over -1. Where 1 is negative, right? Here where I get -1, I get -1. That's this point right here. It's going to turn out to be an inflection point, okay? All right, let's think about +1. Well, if I plug in a +1, notice I get this symmetrical point. These graphs are symmetrical. The graph itself has symmetry. In fact, it has symmetry to the origin, okay? If we were to say, well, you know, we're going to do a little reflection line. If you notice, this is going to be symmetrical to this line drawn through the origin, okay? And then, well, if I do -2, notice at -2, I get, well, that should be -1/2, and it is. At x equals -2, this is -1/2. Notice the scale. And if I do +2, right, I'm going to get +1/2, again, with that symmetry, okay? I'm going to get this +2, +1/2 right there. What about a fraction? What if I did, I meant to do the 2/1/2 here. Okay, what if I did a fraction here? What if I put in 1/2? Well, 1 divided by 1/2 is 1 times the reciprocal, 2. So at x equals 1/2, which would be here, the function should equal 2, okay? The reciprocal, right? That makes sense. These are reciprocals. So I put in the fraction, I'm going to get the reciprocal of the fraction, right? Okay? So you see how this graph is kind of put together. And if I did a sign chart with this, it'd be a pretty, very simple one. Remember I told you treat x like it's a 0, but really what we're doing is we're finding a critical value. And it turns out that division by 0 creates a critical value. Notice that is a value that x cannot be, right? Okay, so no matter what, x will have a bubble here. If I'm talking about all the solutions, right? And then it's just a matter of, is it going to be greater than or less than? So I'm going to say greater than, right, 0. Notice I can't even try to say greater than or equal to 0. Will this function ever equal 0? It can't. You can see, by the way, it can't, because if I can't put 0 in the denominator, I'll never get 1 over something equal to 0. So as far as this goes, we'll never be able to get that. We're only going to be able to look for, say, the positive. And if you notice, the way we did that is you'd look at this, well, you know, sign chart, right? X, you know, if I think about 0 is a critical value here. This is 0, okay? And I'm going to bubble that, right? That's then, okay, well, everything over here is negative and everything over here is positive, and oh, here's my solution set right here, okay? So I could apply the sign chart mentality, but if you know what the graph looks like and you know what the function is, you can just logic your way through this. Everything that's positive is going to be to the left of 0, okay? So that's the basic rational function, and it turns out that every one of these other rational functions are going to follow a similar mentality, okay? So let's go to the next one, okay? So this one, I believe, is number 63, okay? We're gonna graph this one. So notice, let's take a look at what we would expect based on the graph for this solution to be. In the book, it says we want the values that are less than 0. We want the negative values. Well, anything below the x-axis is negative. So it's positive, decrease, everything here is positive, decreasing, though, the function going from left to right is going to be decreasing. Everything I'm talking about is coming up in chapters 2 and 3. We get to -2, and there we go. So everything this way forward here, this is my negative, right? Everything down here. So from here, it's going to race towards negative infinity on the y-axis, but notice it will never get to 0. So we have to circle 0 because it'll never get there, okay? So our x values that will give a negative y value, just pay attention, would be -2, 0. This part here, I get negative values, okay? Then all of a sudden, it's positive. Notice it's racing towards positive infinity on the y-axis. But coming down from, you could also say, but again, from left to right, we're going this way, and then we finally get to +2, right? And from +2 all the way down here, right, it's negative again. And if you notice, based on the trajectory of this line, it's just going to go to negative, it'll stay negative all the way through x to infinity, right? Okay, so I can graph my solution this way. So this is what my solution should be. If I do a sign chart, this is what it should tell me, okay? So let's see what that looks like in a sign chart, okay? So here we said we wanted less than 0. We want the negative values, right? Okay, so in order to get, and we're using 0 for these critical values, I need to get one rational expression, a numerator and a denominator only. And I get that using my 1.4 skills, where I turn that x into an x over x, which gets me to a common denominator, right? So this is 4 minus x squared over x, which would be 2 minus x times 2 plus x, right, over x, okay? So this simplifies, and we want everything less than 0, okay? So again, we're looking for the sign chart to give us exactly what we saw here. Well, we do treat these two as factors because in the numerator, that's going to give us a 0, right? That should make sense. -2 and +2 will make the function 0. So we're going to treat those as zeros, 0 factors. The part, though, that's a little trippy is here I'm not treating x as a 0 because, of course, that would violate my division by 0. I'm treating this as a 0 here in the denominator becomes what I call a critical value. It's a value that x cannot be, okay? And if you notice, x cannot be 0, okay? So those are my 3 critical values: 0, 2, -2. Okay, so now I'm just doing the same thing with the sign chart because you're not being given graphs, right? So we should be able to do this algebraically without having to actually graph it. We're going to get our numbers to plug in. Here we go. So these are going to be my plug-in numbers. Okay, 2 minus -3 is 2 plus 3, which would be positive. 2 minus -1 would be 2 plus 1, which would be positive. 2 minus 1 is still positive. 2 minus 3 is negative. Okay. All right. 2 minus 3 is negative. 2 minus 1 is positive. 2 plus 1, 2 plus 3. And then these, you just follow the signs. I'm just plugging these in, right? Look at my chart. This is positive. This is negative. Again, I'm looking at the number. The negative times the negative will be a positive. This has one lonely negative, so that's a negative. I had to do, what have I done? Well, this is a positive, yes, here. And then one negative turns this negative, okay? So what I have is these 3 are my critical values, right? I would always open circle them because I have an original without a line. But if I did have that line, notice I would still need to open circle 0 because I can't divide by 0. So if I had a line under here, I would bubble in these 2 zeros, but I would not bubble in the negative and the positive 2 values because they are zeros, but I wouldn't bubble in the 0. Okay, but I'm going to go back to the original here. Okay, not to confuse. And notice that this is exactly what I expected. I want the negative values, so I'm going to do this one here and this one here. That's exactly what we came up with here, right? From here to here, it's negative. From here to here, it's negative. And then we just turn this into our interval notation, -2, comma, 0, union, +2, infinity. Okay, so the whole purpose of the sign chart, guys, is so that you don't have to graph something to know where the function is positive or negative. And so that's kind of the skill that this chapter is teaching you. But hopefully by showing you the graph and showing you the logic of why am I treating the x that's in the denominator as a 0 when it can't even be there, right? We're really testing what we call critical values when it comes down to these rational functions. You notice this again, I have a rational expression here. I need to create my common denominators to get this to be essentially one denominator, one numerator, okay? Right, so what I'm going to do is I'm going to re-express this as 2x plus 1 minus, I'm going to do my 3 times, right? This is going to be the quantity minus the quantity, okay? 3 times the quantity x minus 5, being careful, right? And that will give me everything over x minus 5, still less than 0. And then that kind of simplifies out. I'm going to get a 2x minus a 3x. I'm going to get a negative x, and I'm going to get 1 minus, that's going to be a plus. So it's going to be 15, positive 15 plus 1 plus 16, okay, over x minus 5, okay? And that's basically what I'm saying is I want to know where does this expression here where on my graph is it less than or equal to 0, okay? All right, so without having to get the graph, I'm just going to break this out. Here's what we're doing. The negative x plus 16, that will make the numerator 0, which would make this less than or equal to 0. So we're looking at that as a critical value, okay? So I'm going to put that will be, if x was 16, right? Isn't that what we're saying here? If x is 16, this would be a 0. That would be a solution there. But the other critical value that we have to take into account is that if x were 5, right, then, well, that would give me 0 in the denominator. Denominator cannot equal 0, but that actually becomes a critical value, okay? I am going to be careful to circle this one open, though, because notice this one has an inclusive, but I cannot have 5 because it's in the denominator. It would create a 0. So I have two values that are critical values. One is open circle, one is closed, okay? So I'm going to create my little zones here. And I've written down one of my factors here. The other one is x minus 5. So now I guess I might as well test 0. That's pretty easy. Maybe I'll test 10. Maybe I'll test 20. Okay, just picking some other numbers that fall within these ranges. Plugging 0 in here, well, 0 plus 16 is positive. 0 minus 5 is negative. So my function should be negative down here in this territory here. If I plug in a 10, negative 10 plus 16 is still positive. 10 minus 5 is positive, so this is positive. And then I'm going to do 20. Negative 20 plus 16 is negative. 20 minus 5 is positive. This would be negative. Again, I'm doing this times this, or basically do I have just an odd number of negatives? Going back here, I do want the negative territory, okay? So my solution should be this bubble 5 going towards the left, right? And then this solid 16 going towards the right. And that would give me this solution here, okay? Should be positive infinity. I'm looking at the 20 down here, but this is obviously going off to infinity. All right, so if you do at this point want to verify your function, you could go back to Desmos. All right, so I've graphed the function on Desmos. I just typed it in. And if I want to, by the way, I can kind of drag this around here, right? I could zoom in or out. I want to. I think I'm going to do that. That's going to make it a little bit easier to see. And what I'm going to do here is I'm going to basically graph on the x-axis that solution that we came up with. The solution, what I did is where x was 5, right? Let's say there, we had a bubble. And then it said that everything to the left, right, was going to be negative. And then it picked up again at positive 16, okay, which would be, this is 10, 12, 14, there we go, there's 16, okay. So we wanted this to be less than or equal to 0, so at this point 16 it is 0, and then our solution went in this direction, right, okay. Do you notice that this graph exactly follows this, that everything about the function is negative, right, from this point over? Then what we have is this asymptote. This one's at 5, positive 5, because positive 5, right, if you notice that line, positive 5 would make the denominator 0, so it cannot be a value. It's considered a critical value. So it's not going to be either positive nor negative, right? And there you go. So this is for you to be able to see how your solution matches the way you're doing things with the sign chart, okay?